Hello everybody, today we will discuss about the Barplot for two-way ANOVA. In the previous tutorial we tried to discuss about the one-way ANOVA using our studio. So today we will continue the second phase. So in order to draw the bar plot or the bar chart for two-way ANOVA in our studio or in our software, the following package: ggplot, tplayer, multicom view as well as agricola are required. So you have to incorporate your studio, type this one and run to your studio. And I already imported the data in order to save time. So my data contains three different variables. The first two are the genotype and irrigation as the factor, while the GUI is the response variable. So the genotype contains Howie, Oda, and Melka genotypes, while the irrigation level is 20 and 40, as you see here. Then don't forget here to change your data structure, especially by checking your data structure. If it is numeric or character, you have to convert into factor using as.factor function as described here. So you have to convert, especially your treatment. In your case, the treatment is a genotype and the irrigation. So you may not be worried about for response variable or for GUI or bring it. So let's proceed to analysis of variance. So in order to create ANOVA, you have to use a function analysis of variance, and here is the GUI is the response variable, which stands for grain yield, and as explained by genotype, and these 2 points indicate that the interaction. So you can also use interchangeably the asterisk. So here irrigation, and you have to indicate your data name. So our data name here is Ako. So type this one and run to your studio. Then immediately for this tutorial I use the mean separation is TAKE honest significance difference or TAKE HCD. So you can assign any name that you want here. Then you have to use a TAKE function which is built in agricola package. So type this one. ANOVA is what we created here. So type this one and run to your studio. Then immediately we can create the compact letter display or the CLD. So in order to do that, we have to use the multicomp letter 4, which is built in the multicomp package. Then you have to use, here is ANOVA, and also at the same time you have to use this TAKE. TAKE means TAKE honest significance difference under parenthesis ANOVA. So type this one and run to your studio. Then immediately we can also create a search quantiles with the factors. So in order to do that, we have to use all this syntax. So this means that WQ, or you can give any name that you want. So AQ stands for data, or my data, or maybe it's your data. Then also you can group. You have to use the function group by. Group by means here is irrigation and genotype, because we are going to for two-way ANOVA. If it is for one-way ANOVA, it will be either IRR or genotype. So the difference is here. Then we have to summarize W is equals to mean of the grain yield, and the standard deviation is which is equals to standard deviation of the grain yield over the square root of the length of the GUI. So if the length of GUI is 20, it will be 20. So by this way you can incorporate your studio, or you can create a table with factors and search quantiles. So type this one and jump to another way. So the other one is the we can extract the compact layer, especially by adding the TK table. So in order to do that, we have to say here CLD2. Maybe you can also give an alternative name. So you can, for the sake of this tutorial, I already mentioned CLD2, and here is a data frame is a function, and the letters which calls to the CLD what we created here, or the compact layer display, and here is the interaction effect that we desired to create a bar plot. So this genotype interacted with irrigation, and also we have to display this letter. So type this and run. So if you are not incorporate this one completely, our plot or the bar plot will be messed. So it is boring, and even it is very complex, and it's not attractive, so it doesn't represent the real bar plot. So I recommend you to follow this step. So then W key is what we create here is. So you have to attach using the dollar sign and CLD, and in similar fashion you have to do the second one. So type this and run to your studio. Then let's see by printing the WK. Yes. So as you see here, there is Howie with 20, Malka with 20, Oda with 20. Here is W means is the mean of the granule. Here is the standard deviation, and here is the compact layer display, or the significance letter. So by this way you can also identify in this table form. Then let's go to the ggplot. So the other one is the ggplot, which is built in the package ggplot. So here is a ggplot function. WK is what we create here, and the axis is, let's say here is irrigation, or alternatively you can also change it to genotype, but I will show you different forms. So y, which equals to the mean of the granule that represented here. So it's already similar to the previous title, the previous tutorial. So the geometry bar, which equals to start, is equals to identity, axis field equals to irrigation, and also show legend, which equals to true. And you can also may also say false if you don't want to display your legend. Additionally, you can also go for error bar. So the minimum is mean of the gradient minus standard deviation, and the maximum of the error bar is the mean of the gradient plus standard deviation. The width of the error bar is 0.2. Also you can limit on the basis of your preference. Then also the x-axis or and as well as the y-axis, you can represent x is equal to genotype, y is equal to granule. But for this case, x-axis is irrigation, so you can also change here into irrigation, and the y is the granule. As well as the geometry text, the label is the compact layer display. That means in the form of B, C, A, or D, something like that. Then the y limit, which equals to the mean of the granule plus standard deviation, plus the vertical adjustment is negative 0.5, and lastly the phasor trap, which equals to the genotype. So let's run this. Yes. As you see here, the legend shows that irrigation with a level of 20 and 40. Here is 20 and 40. Again also 20 and 40, 20 and 40. And here also the variety or the genotype is Howie for 20 is around 25, and also the 40 around 75, which is designated as what as BC. And around here is Malka for irrigation level is 20 around AV. By this way also you can represent. Alternatively, you can change also the x-axis from irrigation to genotype. In order to do that, you have to write here is genotype, and also you can also change the feeling either into genotype or irrigation. So if it is genotype here, you have to display here irrigation, IRR. So let's see some combinations. Yes, it is different from the previous one. Again, here is the irrigation IRR already display here. The reason behind this is that as you see here, the field is represented by what? By irrigation. By irrigation. So if you write IRR here, so there will be two levels. One is here is the irrigation with 20 level, as you see here is irrigation 20 with different genotype, as well as irrigation 40 with different genotype. And again, we also let's check by changing this into genotype. Let's type this, and also you can change the x-axis name into genotype. Genotypes. So type this one and run. Yes, as you see here is how is designated by somehow by red or some color. Here is Malka is represented by green, and Oda is by blue. Even also here also the legends display in this way, and the irrigation level is 20, the irrigation level is 40. So by this way you can represent in different forms of the two-way ANOVA using our studio. And more or less, if you want to remove this legend, you have to convert the show legend into false. So if you write this, automatically the legend will be removed from the bar plot. Yes, so here is removed from the bar plot. So in this way you can represent your Barplot in different forms. And if you have any question regarding to my tutorials, you can address me through my email wagzlatasfaun@gmail.com, or alternatively you can use my the YouTube comment box. Thank you for watching.